Hello everyone, welcome back to Let's Solve. Today's topic is El Nino and La Nina. First of all, let's take a look at the previous year question which was asked from this topic. It was in 2011. La Nina is suspected to have caused recent floods in Australia. How is La Nina different from El Nino? So two statement question, the difference between La Nina and El Nino. Another thing you have to notice in this question, it's a current affair related question, right? Recent floods in Australia was due to La Nina, and they have asked a question related to the difference between El Nino and La Nina. So there's a tendency that, like in the weather events which are in news, there are more chances, like in a UPSC will be asking questions based on those weather events which are in news. Okay, so let's take a look at what is El Nino and La Nina. First of all, you have to remember the trade wind. Okay, the trade wind is a prevailing wind in the tropical latitude which is blowing from east towards the west, or it's moving towards the west. Okay, so in this picture you can see on the eastern side we have like the South America and the North America, and on the western side we are having Australia and Indonesia. So this is the Pacific Ocean. In this picture you have to imagine it as the Pacific Ocean, right? Especially in the picture it is given as the equatorial Pacific waters. Okay, so the trade wind is blowing from east to the west, right? While the wind is moving in this direction, the surface ocean water will also be carried along with the trade wind, right? You might be knowing, like if you are having a bowl of water and if you are blowing in this water, right, we'll be able to see that as we blow, the water also will start to move. The same way, while the trade wind is moving or blowing, like they will be carrying the ocean water along with them, right? Now next thing you have to remember, if you take an ocean, consider the oceans, the surface ocean water will be the warmest because it is being directly heated by the sunlight. So while the trade winds are moving from east to the west, the warm surface water in the equatorial Pacific Ocean will be carried towards the western Pacific Ocean, right? So the warm water will get collected in the western Pacific Ocean. Near the eastern coast of Australia and Indonesia will be having the warm water will be collected over here, right? And then next thing you have to remember, like wherever we are having warm conditions, we will be having low pressure there, right? Because like if you are having warm conditions, the air will be expanding and the density will reduce and we will be having low pressure. So you just have to remember that wherever we are having warm condition, we will be having low pressure there, and wherever we are having cold conditions like cold water or cold land, the pressure there, the air pressure there will be high, right? So warm conditions, low pressure. Like cold conditions, we'll be having high pressure. So here if you guess, where we'll be having like the low pressure? Since the warm water is collected over the western Pacific, here we'll be having low pressure regions, right? The next thing you have to remember that wherever we are having the low pressure, the air will always ascend, right? They will always be going up, right? Wherever we are having the high pressure, the air will be descending. Okay, so in this picture, as you can see, here we'll be having warm water and the low pressure will be situated here, right, in the western Pacific. And through this western Pacific, upward, the air will be moving, the air will be ascending, right? So the trade winds, they are coming towards the western Pacific, and due to the collection of warm water here, the winds, the air, they are going up, right? And this going up air will be going towards the eastern Pacific and it will be subducting or descending in the eastern Pacific, completing that circulation, right? So this is the normal condition in the Pacific waters. The trade wind is blowing from east to west, the warm water getting collected over the western Pacific, and this air is going up to complete the circulation and descending in the eastern Pacific, right? So let's briefly discuss what are the conditions. Like in the case of ocean water, right, we'll be having comparatively warm water in the western Pacific, and we'll be having colder water in the eastern Pacific. And should be remembering that, like this topic is a bit related with the ocean current. There are two kinds of ocean current very broadly, like warm current and cold current. So cold current is the ocean water moving from the depth of the ocean upwelling towards the surface. Upwelling means coming towards the surface, right? So here in the eastern Pacific, since the surface water is blowing towards the west, in order to compensate that loss of the surface water, the water from the depth will be rising up, meaning that here the ocean water will be cold. Okay, so in normal conditions, we are having the cold ocean water in the eastern Pacific and warm water in the western Pacific. Now think about this, if you can remember, what is a cold current in the western coast of South America, right? In the Peruvian coast. Obviously the Peruvian cold current, or other name is Humboldt current. So this is the ocean condition during the normal condition. Warm water on the Western Pacific, cold water on the Eastern Pacific, right? The next thing is the case of air pressure. Okay, in the Western Pacific, because of the piling up of the warm water, we will be having low pressure here. And due to the subsidence of the air in the Eastern Pacific, we will be having high pressure over here, right, in the Eastern Pacific. So this is the normal condition, and from this you have to remember one term which is called as Walker circulation, right? Walker circulation means this atmospheric air circulation, like the air through the surface coming as trade wind, and it is going up, creating the clouds here, and it is going back and descending in the like the Eastern Pacific. So this movement is actually, you should remember that the trade wind is blowing through the surface, right, near the ocean surface, and the other part it's ascending, and then in order to complete the circulation, it's going back through the upper air circulation, through the upper layer of the troposphere. Okay, so this circulation we call it as Walker circulation. Sometimes this term can come in a statement like the Walker circulation will be distorted due to the El Nino or La Nina condition, right? So remember this term, Walker circulation. And next, let's take a look at another picture showing the same normal condition, or other word is neutral year. Neutral year means it's neither a La Nina nor a El Nino year, right? So in a neutral year, as you can see here, the trade wind will be blowing from the South America towards the Australian regions. Warm water piles up over here, it goes up creating clouds and goes back, like the air goes back in order to complete the circulation. The circulation is called as Walker circulation. And here you can also find like the case of ocean water, because the warm surface water is moving towards the west. In order to compensate that, the cold water will be coming upward. Okay, so this is a case of a neutral year or normal conditions in the equatorial water. Next, let's take a look at the El Nino conditions. So during El Nino, you have to remember that, right, the trade wind is weakened, or the trade wind is reversed, right? Like this is actually a cyclic process. Like we'll explain why the trade wind is weakening, and this process is a very slow process, and it takes 1 or 2 or 3 years for the formation of El Nino, right? So in simple terms, El Nino means the unusual warming of the Eastern Pacific Ocean. In the normal condition, we have seen that in the Eastern Pacific Ocean, the water is actually cold, right? Opposite to this, like the opposite to the normal condition, during an El Nino, we'll be having like the warm water will be piling up over the Eastern Pacific Ocean, right? So imagine this, if the trade wind is weakening. Earlier, the trade wind was moving from east to west. Now imagine that the trade wind is weakened, or the trade wind has reversed, and the trade wind is moving from west to east. So earlier, in the normal condition, the warm water was piling up over the Western Pacific because of the direction of the trade wind, right? Since here during an El Nino year, since the trade wind is reversed, okay, the warm water won't be coming towards the Western Pacific. Rather than that, the warm water will stay there in the equatorial Pacific itself. Okay, so the warm water is over the Eastern Pacific Ocean, right? It's not coming towards the Western Pacific, rather than it's staying over the coast of, like equatorial coast of South America, right? So the ocean condition here will be like the ocean will be warmer in the Eastern Pacific, and comparatively it will be colder in the Western Pacific, because in an earlier case the warm water was coming towards the west because of the trade wind, right? So now compared to that normal condition, the Western Pacific is actually now colder, and the Eastern Pacific is warmer, right? So the ocean condition, as I said, warm water over the Eastern Pacific, cold water over the Western Pacific. Now let's look at the air pressure. Okay, so wherever we are having warm water, we will be having low pressure there. So guess, in this case, in El Nino year, where will we be having low pressure? In the Eastern Pacific, we will be having low pressure, and the high pressure will be in the the Western Pacific. Now imagine the air will be ascending in the low pressure, and the air will be descending in the high pressure region. So what happens is that the trade wind which is here, which has reversed, is now blowing from west to east, and from the equatorial Pacific Ocean, it is rising up, and then it is coming towards the Western Pacific and descending in the Western Pacific in order to complete the circulation. So earlier we have seen that the Walker circulation, right? here in case of El Nino, the Walker circulation is now reversed because the trade wind has reversed direction, the air pressure has reversed the position. Okay. Now think about this. Wherever we are having ascending air or the air going upward, all the water vapor, dust particles, everything will be carried upward, resulting in more cloud formation. So wherever we are having upward moving air, we will be having more rainfall over there, right? So during the normal condition, right, the more rainfall was there for the Australia or the Indonesian coast, right? But here, during an El Nino year, more rainfall will be there for the South American coast because the air is ascending there. More clouds will be building up there. At the same time, for the Australia and the Indonesian region, since the air is descending, okay, the cloud formations will be discouraged and rainfall will be reduced. So these are the direct impacts of El Nino. During El Nino, more rainfall will be for the South American coast or the Eastern Pacific, right? And the reduced precipitation will be there in the Western Pacific. Next, let's see the important points in the formation of the El Nino. So we started with the reversed or weakened trade wind, right? So reversed or weakened trade winds means it reduces the amount of surface water which is pushed towards the west, and that means we'll be having reduced upwelling, right? Upwelling means the cold ocean water coming from the depth of the ocean towards the surface. Since the surface water, if the warm surface water is staying there in the Eastern Pacific, right, the upwelling will be reduced. And due to all this thing, right, due to all this process, the warm water piles up in the Eastern Pacific Ocean, right? This can be Eastern as well as the Central Pacific, right? So the warm water piles up in the Eastern and Central Pacific, and the warm water reduces the air pressure over the Eastern Pacific, right? Now if you look at the air pressure, right, the low pressure is over the Eastern Pacific and high pressure is over the Western Pacific, which is actually not suitable for the formation of normal trade wind. So this process actually weakens the pressure gradient. I mean, pressure gradient means difference in pressure, right? The air is due to the difference in pressure. So this reduces the pressure gradient, and thus in turn the trade wind is weakened or reversed. So this is actually a reverse or a cyclic process, right? The weakening of trade wind is actually due to the weakened pressure gradient, and that is the pressure gradient is weakened because of the weakened trade wind. Okay, so that's actually cyclic process, and this doesn't take place all of a sudden, right? And you have to understand that in El Nino forms by taking say 1 year or 2 years, right? So gradually the trade wind will be blowing or will be weakening, and the water carried towards the Western Pacific will be reduced, which in turn reduces the pressure gradient, and that in turn reduces or weakens the trade wind, and sometimes the trade wind can even reverse. Okay, so this is the case of El Nino. Now let's look at the case of La Nina. Now regarding La Nina, you have to remember that La Nina is an intensified normal condition or intensified neutral year. Okay, in case of the neutral year or normal condition, we have seen that the trade wind which moves from east to the west, right? In case of La Nina, these trade winds will be attaining more strength. So that means they will be blowing with more velocity, and more water will be carried towards the Western Pacific, right? So unusually warm surface water will be there in the Western Pacific, and unusually in the sense compared to the normal condition. So unusually very cold water will be there in the Eastern Pacific, as again we will be having very intensified the Walker circulation. The more rainfall will be there for the Australia, and we will be having very dry conditions in case of South America. Now this is the case of La Nina. So La Nina is an intensified normal condition, and El Nino is a reversal of a normal condition. The Walker circulation in case of La Nina will be intensified, and Walker circulation in case of El Nino will be reversed. Okay, now let's actually compare these two events. Now before going to the comparison, you have to understand that El Nino and La Nina, they are actually two phases, right? And this common process we call it as ENSO, El Nino Southern Oscillation, right? ENSO, E-N-S-O, El Nino Southern Oscillation. Now this weather event, the El Nino Southern Oscillation, it's having two phases. First phase is El Nino, which you have already seen, and the other phase is, right? So if the equatorial or this, if the equatorial Eastern and Central Pacific water, if it is unusually warm, right, we'll be having El Nino condition. if the equatorial, like eastern or like the central Pacific water is unusually cold, we'll be having La Nina condition. So these two events, they are the two different phases of the event called as El Nino Southern Oscillation. Now let's compare the features of El Nino and La Nina. The first one, trade wind. In case of El Nino, the trade wind will be reversed or will be weakened. And in case of La Nina, we'll be having intensified or hard trade winds, right? Now the sea surface temperature. In case of El Nino, the central and eastern Pacific is warmer and the western Pacific is colder. And the case of La Nina, the western Pacific is warmer than normal, right? Because like more trade wind is carrying like large amount of water towards the western Pacific during the La Nina year. And the case of central and eastern Pacific, in case of La Nina, it will be very cold, right? Now upwelling will be very intensified in case of La Nina. Okay. Now next one is the case of air pressure, right? So we have talked about the sea surface temperature. Now the next feature is air pressure. The eastern or central Pacific will be having low pressure during El Nino, and during in case of like western Pacific during El Nino, we'll be having high pressure. Okay. And comparing to this, the La Nina, like the western Pacific will be low pressure and eastern Pacific will be very high pressure. Okay, because of the intensified like the upwelling taking place at the during the La Nina years, right? And in case of the feature upwelling, reduced upwelling during El Nino because of warm water is staying there in the that Pacific, eastern Pacific itself. And in case of La Nina, we'll be having intensified or increased upwelling. Usually during normal condition also we are having upwelling taking place in the eastern Pacific. But due to during the La Nina year, due to the strong trade winds, this upwelling will be intensified or increased. Now the next feature is rainfall. During El Nino, the low pressure is situated over the eastern Pacific. And as we have seen earlier, wherever we are having low pressure, the air will be going up, creating more clouds and giving more precipitation. So as a direct effect of El Nino, we will be having increased rainfall over the eastern or central Pacific. And in the western Pacific, due to the subsidence or the descending wind, we will be having clear sky and the precipitation will be very low in western Pacific during El Nino. Now in case of La Nina, the reversal will be the case, right? The eastern Pacific will be like having very arid conditions and like the precipitation will be very less, and the western Pacific will be having unusually high precipitation. The next feature, like the effect on India. Let's see how El Nino and La Nina is impacting India. Now from the previous record, historical data, El Nino years will be having reduced precipitation, right? In the sense like below normal monsoonal rainfall will be there during the El Nino, and that condition will lead to like drought conditions. The last El Nino year, like 2014 to 15, if you remember, we had back-to-back drought conditions during that last El Nino year. Okay, and during the La Nina year, okay, we'll be having like above normal rainfall, which is favorable for India, but this like an intensified rainfall can sometimes result in flooding. So flooding conditions will be there during La Nina year and drought conditions will be there in El Nino year. So this is the general comparison between the El Nino and La Nina, and certain statements or certain trivia which you need to remember regarding El Nino and La Nina. Like most often an El Nino will be followed by a La Nina, but this need not be the case always. So sometimes the statement can be like El Nino will always be followed by La Nina, which is actually wrong. El Nino will be mostly followed by La Nina, right? Even that is actually wrong, because around 40% of El Nino is followed by La Nina. So like it can be like El Nino can be followed by La Nina years, which is actually true, right? And every El Nino year may not be resulting in deficient monsoon for India's case, right? There are whether other events like say Indian Ocean dipole or the conditions in the Indian Ocean, right? Sometimes the conditions in the Indian Ocean will be so favorable for the Indian monsoon, so much so that even during an El Nino year, we'll be having normal monsoon rainfall, right? So if there's a statement like all El Nino years will be having deficient monsoon rainfall, which is actually wrong. So look out for the keyword here in the statements. But anyway, as general impact or effect on like India's case, during El Nino, we'll be having reduced or deficient monsoon rainfall that can lead to drought conditions. And like in the case of La Nina, we'll be having increased rainfall, above normal rainfall, and which can lead to flooding conditions. Now, let's solve the previous question which was asked from this topic in 2011. So La Nina is suspected to have caused recent floods in Australia. How is La Nina different from El Nino? Right? So the first statement, La Nina is characterized by unusually cold ocean temperature in equatorial Indian Ocean, whereas El Nino is characterized by unusually warm ocean temperature in the equatorial Pacific Ocean. So here if you closely look at the statement, it's in the case of La Nina, the first part of the statement, it's been given here as Indian Ocean, which is actually wrong. La Nina and El Nino, both are events, both are different phases of ENSO, right? El Nino Southern Oscillation, which is taking place in the equatorial Pacific water. So I would say around say 80% of the statement is actually correct. Here instead of like equatorial Indian Ocean, it should have been equatorial like Pacific Ocean, right? Equatorial Eastern Pacific Ocean. Then the first part of the statement could have been correct. Now, anyway, the first statement is wrong. The second one, El Nino has adverse effect on southwest monsoon of India, but La Nina has no effect on monsoon climate. As you have seen earlier, during an El Nino, we will be having adverse effect, in the sense deficient monsoon rainfall. So half of the second statement is actually correct, but the second part, La Nina has no effect on monsoon climate, which is actually wrong. During La Nina, there are more chances that we'll be having above normal rainfall. So it again, the second statement is also wrong. So here the answer would come out as D, which is neither 1 or 2. So again you have to notice that this is a current affair question. So the general tendency is that whenever like these weather events are in news, we'll be having questions coming from these events, right? So in 2011, it was asked because like the El Nino La Nina was in news. Same way, like this year, right? It is going to be an El Nino year. There are like various weather forecasts and weather predictions that this year it's going to be an El Nino year. So if like this is going to be an El Nino year, you can expect a question for your 2019 prelims based on like El Nino or La Nina, right? So prepare this topic thoroughly.